In this video, we're going to look at a basic introduction to the sine rule and the cosine rule. We would use either the sine rule or the cosine rule to find missing lengths or missing angles in non-right angle triangles. In the video, we're not going to solve any problems, we're just going to look at which rule we would use for a particular question. So, let's start off with a bit of basic revision. What I'm going to do here is draw three right angle triangles. So if I put one here, and one here, what we're going to do is look at finding missing lengths and missing angles in right angle triangles. So we'll know it's right angle as you'll have a right angle here. If we've got two given sides, for example 3 and 4, we can find the missing length using Pythagoras theorem. So Pythagoras theorem. We know with Pythagoras theorem, a squared plus b squared is equal to c squared. So in this particular case, 3 squared plus 4 squared is equal to x squared. We can still use Pythagoras theorem. Just because we're now learning the sine and the cosine rule doesn't mean that we can forget these. You can use the sine rule and the cosine rule with right angle triangles, but generally speaking, for a missing length or a missing angle in a right angle triangle, we'll use either Pythagoras theorem or the trig ratios. If I've got now a given angle, so I've got one angle and the right angle, let's say for example this is 42 degrees, and I've got one given side length, let's say this is 6.1, I can find y or z using what we call the trig ratios or SOH CAH TOA. Again, these are still very valid and you will still need to use them. So let's go ahead and do that. If we wanted to find a missing angle in a right angle triangle when we're given two sides, for example this one could be 5.2 and this one could be 7.1, we would again use the trig ratios SOH CAH TOA. These again are still going to need to be in your toolkit to solve for triangles. What we're now going to do is look at situations where we don't have right angle triangles. I'm going to start off by looking at finding missing lengths. So let's write this out, missing lengths. We've got a choice of either the sine rule or the cosine rule. I always think it's easier when we're doing a problem on which one to use to look at the cosine rule first. So on the left I'm going to have cosine rule problems, and on the right I'm going to have sine rule problems. I'm just going to draw some non-right angle triangles, so let's just put on here, we will have, let's put 4 on here, so that's what we'll have, and then we'll do 4 over here, and I appreciate these are very similar, but we can just alter the numbers and letters accordingly. So with the cosine rule, when we're trying to find a missing length, we will always have two sides given and we will have one angle, and that angle will be enclosed. So if you have two sides, generally speaking, and one angle, and that angle is enclosed, then we can use the cosine rule. So for example, if I'm given now this angle is going to be 110 degrees, I'm told that this is going to be 7.1 and this 5.9, I can find the length right here which will be opposite the enclosed angle by using the cosine rule. Two sides and an enclosed angle. The 110 degrees is enclosed between the side of 7.1 and the side of 5.9. Let's look at another example. Let's say this angle is going to be 39 degrees. This length right here is going to be 3.2 and this one is going to be 5.1. We can find this length right here, which I will call y, by using the cosine rule. We have an angle, one angle enclosed by two sides. I'm saying generally speaking with this idea of two angles, two sides and one angle, the same when we get onto the sine rule. There might be multi-step problems where you link different rules. Again, we will look at that in the video when we do the sine rule and the cosine rule and some exam style questions. We'll look at one more example. Let's say we've got this angle right here and we're told this is 52 degrees. we're told that this length right here is going to be, we'll go for 11.4 centimetres, and we're told that this one is going to be 7.8 centimetres. We can find this side length Z as we've got two known sides and enclosed angle. That is when the cosine rule comes in. So let's look at this generally and look at the formula we would use. If we have this angle, which I'm going to write as capital A, the opposite side will be little a, or lowercase a. I can call this one B or this one B, this one C or this one C. I'm going to put that this is B and this is C. With the cosine rule, which you'll need to memorise, A squared, which is going to be this length squared, will be equal to B squared plus C squared minus 2 multiplied now, and let's leave the bracket off, don't leave the bracket on here, 2 multiplied by B multiplied by C, so writing this in, 2BC cos A. That is the cosine rule to find a missing length. This will give you A squared. Clearly, if you want A, you need to square root this. So, for example, if I just applied this to 1, and we will go through 1 very quickly, if I wanted to find the length x here, I would just write on which these are. So, if I wanted to find x, this is A, this is A, this can be B, and this can be C. I could have called those the other way around. It really doesn't matter. So what I can say here is x squared is equal to B squared, which is 7.1 squared, plus C squared, which is 5.9 squared, minus 2B, which is the 7.1, multiplied by C, which is 5.9, multiplied by the cosine of 110 degrees. And that will give me x squared. So in a calculator, if you wanted to find x, you could say that it's the square root of 7.1 squared plus the 5.9 squared minus 2 multiplied by the 7.1 multiplied now by the 5.9 multiplied by the cosine, and we just hit cos, of 110 degrees. Do make sure there's a little d there. That means you're in degrees. If you're not in degrees, hit shift mode 3. That tells us that that length right there is 10.67, correct to 2 decimal places. As stated, I was trying to avoid actually carrying out one of them, but I think whilst we're here, we may as well look at it. So that now is using the cosine rule. I always think when students say, well, I don't know which is which, I'm really struggling. Cosine rule, think enclosed angle. Sine rule, no enclosed angle. Generally speaking, when we use the sine rule to find a missing length, what we'll have is 2 angles and 1 side. So 2 angles and 1 side. So let's look at an example of a sine rule problem. If we wanted to find this length, and I'll say that this length is x, we might be given this angle right here, which I'll say is 105 degrees. We may also be given now another side length, which could be, for example, 12, and a given angle. And we'll say that this is going to be 40 degrees. So what we can see here is that we've got 2 angles and 1 side to find the other side. With the cosine rule, we have 2 given sides and 1 angle. If we looked at another scenario, we might be given this angle. Let's say that angle is 41 degrees. We might be asked to find the side length y. We might be told this angle, for example, is 108 degrees. And we might be told that this is going to be 3.1 centimetres. So we've got 2 angles and we've got 1 side. In the video when we look to solve these, we will look at examples where it doesn't seem to match up the way this has. It's not a problem. It's either going to be a case of just writing this angle in, knowing that these sum to 180 degrees, or using an application of the cosine rule first. We'll look at one more, may as well. Let's put this one on right here. Let's say now this one is going to be 46 degrees and we're told that this one is 38 degrees. We might be asked to find the length Z, given now that this length is going to be, let's go for 11.7. In general, if we have, and I'm going to do this really slowly because I think in terms of the way it's presented in books, it's overkill a lot of the time. If we have this angle A and this side length A, this angle B and this side length B, we can say using the sine rule that the length A over the sine of the opposite angle to it will be equal to the length B over the sine of the angle opposite to it. And that is it. In the book it will say is equal to C over sine C, which is blindingly obvious. But if you've got all three, what's the point in trying to find the answer because you've already got it? So for me, this is the sine rule as far as you need to use it. So let's just look at a nice straightforward example. Let's say we wanted to solve this one. What I'm going to say is that this one right here will be A, that will be little a, this is going to be B, and this is going to be little b. So what we could say now is the following. We could say that the side length x divided by the sine of the opposite angle, which is 105 degrees, will be equal to 12 divided by the sine of the opposite angle, which is the sine of 40 degrees. All you need to do to solve this equation is multiply both sides by the sine of 105 degrees. So x would be equal to 12 multiplied by the sine of 105 degrees divided by the sine of 40 degrees. And that will give you the answer. In a calculator, it's nice and straightforward. You can just go ahead and do 12 sine, so let's put this in, sine of 105, and then we divide this now by the sine of 40, and then that will give us that side length right there. So that gives us 18.03, and that's what we have. So, nice and logical, nice and straightforward. So let's just recap. To find a missing length, we have two sides and an enclosed angle cosine rule. I will say to myself, is this a cosine rule problem? If it's not, it's a sine rule problem. Two angles, and generally speaking, one side. Let's now move on and look at missing angles. So we've just looked at missing lengths, missing angles. So missing angles, which one would we use? So let's put a line down the middle. Again, we'll put that there. And then we will consider, I think the easiest one is the cosine rule yet again. I think it's far easier to spot. So cosine rule, and then we will look at the sine rule. We'll look at examples of these. So sine and cosine rule. With the cosine rule, to find a missing angle, we will be given three lengths, and this is why it makes it blindingly obvious. So let's again put up some triangles. So let's put this there, that there, and then we'll put that one there. So let's say we wanted to find this angle right here, and we will call this angle theta. If we were given that this is 11.2, this is going to be 7.9, and this is going to be 14.1, we've got three side lengths, we can find the missing angle. If we were given this angle, for example, is angle x, we were given that this was going to be, let's go for 15.3, we were told this is 9.1, and we were told that this is 12.6. We've got three sides and an angle, cosine rule. One more, straightforward, hopefully you can see. So let's say this is angle y, let's say this is going to be 9, this is going to be 11, and this is going to be, let's say this is 8.1. Three given sides and an angle. In general, if we have now this angle A, and we use capital A, and this side length A, this one B and this one C, we can say that A squared is equal to B squared plus C squared minus 2BC cos A. That is what we learnt. But if you can rearrange this, it's a lot easier to find a missing angle. So this can be rearranged, and if we rearrange it, it gives us that the cosine of the angle, or cos A, is equal to B squared plus C squared minus A squared all over 2BC. If you can either rearrange that equation, which is fairly straightforward, all I've done is added the 2bc cos a to the left hand side. I've subtracted the a squared from the right hand side and then divided through by the 2bc. That's all that's happened. It's just 3 steps. If you can remember that, all the better. Let me just show you what I've done here. So if we start here, a squared is equal to b squared plus c squared minus 2bc cos a. I'm going to add this quantity to both sides. So we've got 2bc cos a plus a squared is equal to b squared plus c squared. I'm now going to make 2bc cos a the subject, so subtracting the a squared from both sides. 2bc cos a will be equal to b squared plus c squared minus a squared. So at this stage, all we want is for cos a, so we just divide by this quantity. So cos a will be equal to b squared plus c squared minus a squared over 2bc. It just makes things easier. As stated though, you can just simply substitute in. So if we wanted to work out any of these problems, we could just go ahead and do it. So for example, with this one, this would be a, this would be little a, this could be b or c, this could be c or b. So what we would say then is that cos of the angle, which is theta, will be equal to a squared, which is 14.1 squared, plus that, sorry, my apologies, the 11, let's do b squared, we need b squared. It's this one we're using, b squared, let's put this in. So we'll have b squared, which is 11.2 squared, plus the 7.9 squared, minus the 14.1 squared, divided by 2 times the b, which is 11.2, multiplied by the c, which is 7.9. In a calculator, if we wanted to do that, what we could do is take now, remember this is going to give us cos theta. I'm going to take the inverse cosine. That is the inverse of cos. Cos and cos to the negative 1 are inverses. This will give me the angle straight away. 11.2 squared plus 7.9 squared minus 14.1 squared, and we divide this now by 2 multiplied by b, which is the 11.2, multiplied by c, which is the 7.9. We will spend lots of time doing this on the actual video on the cosine rule, but I think I may as well show it because you might just go straight at it from here. So it gives us an angle of 93.55 correct to 2 decimal places, and it looks alright. So there we go. Okay, let's now look at the sine rule. When would we use the sine rule for missing angles? I always think, well, if it isn't the cosine rule, which is blindingly obvious, it's going to be the sine rule. So let's look at this. Generally speaking, what we would have are on here 2 given sides. So we'd have 2 sides. Let's just change that. We would have 2 sides. So 2 sides, and we would have 1 angle. So let's look at an example of this. Let's say that this here is angle, and we'll say this is theta. We might be given now that this is 30, let's say that's 38 degrees. Let's say this is going to be 10.5, and this one is going to be 12. So what we've got is 2 given sides for 10.5, and we've got the 12, and we've got 1 given angle, which is the 38 degrees. We would use now the sine rule for this particular example. We could have something else. We might have this angle right here. This angle might, for example, be angle X. We might be given that this one is going to be 102. We might be told that this is going to be now, let's say 14, we'll say 14.1, and this one right here, let's say is going to be 11.2. So again, we've got 2 given sides and a missing angle to find with 1 angle given. With these, you might see that you've got to do multi-step problems. We will look at that in a video, don't panic. So in general, if we've got now this angle right here, which is going to be A, and this side length, which is little a, this angle B, and this side length B, what we can say, as we saw before with the sine rule, is that A over sine A will be equal to B over sine B. But there is an easier way to do it. I prefer to invert these fractions such that we have sine A over A is equal to sine B over B. all we're doing is making our equation to solve slightly easier. You certainly don't have to do it. The disadvantage is that if you're using this particular method, you're going to have the unknown in the bottom of this fraction. So if we just look at this one here, and we'll just label it up, this is going to be A, and this is going to be A. This will be B, and this will be B. So what I can write in this particular case now, using this approach, is that the sine of the angle, which is theta, over the opposite side, which is A, will be equal to the sine of 38 degrees over now its opposite side, which is 10.5. So we can say that sine theta will be 12 sine 38 degrees divided by 10.5. And as you can see, that's a lot easier than sine theta being in here rather than multiplying up and down. That just gives us the sine of the angle. So if we actually wanted the angle, we would say now that theta was equal to the inverse sine by taking the inverse sine of both sides, 12 sine 38 over 10.5. So we could look at this in a calculator. Again, make sure there's a degree, a D there to be in degrees. If not, all you do is hit Shift Mode 3 and it puts it in degrees. You don't want the little r here. Shift Mode 4 puts this in radians mode, which is a different way of measuring angles. So it'll give you completely the wrong answer. So to do the inverse, we press Shift Sine. That's the inverse sine. We've got 12 sine 38. 12, let's put this in, 12 sine 38. And we divide this now by the 10.5. And that will give us now the size of the angle which we want. So that tells me that that angle right there is going to be 44.717. So that's our answer. As you can see, it's not very accurate in terms of the drawing, but that will give us the correct answer. So there we go. That's an introduction of when we would use each rule. All I'm going to do to finish off with now is draw a few triangles and we will decide which one we're going to use. So let's just put a load of triangles up and I'll just put a load on here. These aren't going to be brilliant, but we'll just have some idea. And then we'll choose which one we're going to use to find now a given value. So what I'll do is put on here that we want to find this angle, which we will call theta, and we'll say that this is going to be 10.5. We'll say that this is going to be 13.1 and this is going to be 11.6. So what would we do to use now? Which of the 4 different approaches would we use to find theta? Well, we're looking for a missing angle. Our choices are the sine of a cosine rule. So with this one, it would be the cosine rule as we've got 3 given angles. Let's say I've got this angle right here, and let's say this is 41 degrees. Let's say that this is going to be 115 degrees. We were told now this side length here is given as x, and this one is 13.2. What would we use to find x? Well, here we've got 2 given angles on one side. We've got either the sine rule or the cosine rule to find a missing length. This would be the sine rule. We've got the 2 angles on the one side, and that doesn't give us the one enclosed angle. We need an enclosed angle for the cosine rule. Let's look at this one just here. Let's say that this is going to be 48 degrees. Let's say that this is going to be 16, and this one's going to be 19.4, and we wanted to find the value of y. Y is a missing length, so our choices are the sine or the cosine rule. Well, we've got 2 given sides and an enclosed angle, so that will be the cosine rule. If we look at this one just here, let's say that this is going to be, now we'll say that this is angle y. We will say now that this is going to be 100, let's say 108 degrees. We're going to say now that this length right here is going to be 12 units. And this length right here is going to be 16.1 units. I'm just writing these on. What would we do to find the value of y? Well, y is an angle, so it's sine rule or cosine rule. Which one would we use? Well, we have here now a given angle and 2 sides. This is going to be the sine rule. Unless we got the three sides, it will be the sine rule. So three sides cosine, two sides and an angle is going to be the sine rule. Let's look at another one. Let's say we've got this angle right here, and we said that this angle was going to be Z, and we had now this angle right here, and this angle was going to be, we'll say that this is 61 degrees. Let's say now we were given that this side length, and we'll put this on, let's say now that this is going to be 12, and we're going to say this one right here, and this is slightly interesting, let's say that this one is going to be 10.1. What would we do to find Z? Well, with this one, what we would do is use the sine rule. Whilst we don't have a length opposite Z, what I would do is simply define this length right here, this angle, to be the angle Y. I would use the sine rule with sine Y over 12 is equal to sine of 61 over 10.1 to solve for Y. Once I've got Y and I add it to 61, we can take that from 180 to find Z. Okay, let's look at this one. Let's go for, we'll say that we've got X, we've got Y, and we've got Z. And we've got, for example, here, now let's say we've got 5p, we've got 3p, and we've got, let's say, 3.5p. What would we use to go ahead and find the value of X, Y, and Z? Well, all we would do is use the cosine rule. So nice and logical, nice and straightforward. We've got three given side lengths, and we would use that now to find any of the angles in this particular triangle. We'll do one more. Let's put now an angle here. Let's say this angle is going to be 41 degrees. Let's say this is going to be 10. And let's say that this, for some bizarre reason, was a right angle. We'll pretend the screen's a bit wonky. What would we use to find this length right here, which I will call, let's call this length T? Well, the answer is, if it's a right angle triangle, we could use our trig ratios to find that. We would need the hypotenuse given the opposite in an angle, so we would use the sine ratio. So we know from our trig ratios with right angle triangles, we can do that the sine of the angle is the opposite over the hypotenuse. So don't think just because we've done right angle triangles, that's it. So there we go. That is an introduction to the sine and the cosine rule and which to use when. In the next couple of videos, we will look at the sine rule individually and the cosine rule individually.